Class, in this video we continue our discussion of section 6.4 on the inverse trigonometric functions. And on page 12, on the previous page, we did composites of trig function with its inverse function. And on page 12, the inverse trig function was the inner function and the trig function was the outer function. In this, on page 13, the inverse trig function is now the outer function and the trig function is now the inner function. And since the inverse trig function is the outer function, we know the answer to their composite problem is going to be an angle, since the inverse trig function is the outer function. So in this first example, we got to find the inverse sine of the sine of pi over 4 radians. Well, from the unit circle, the sine of pi over 4 radians is equal to square root of 2 over 2. So our composite is equal to the inverse sine of square root of 2 over 2. And from page 3, we know that the inverse sine of square root of 2 over 2 is equal to pi over 4 radians. So this composite up here is equal to pi over 4 radians. Next, and you'll notice in this example, the inverse sine and the sine function canceled in the composite. And they canceled and we were just left with pi over 4 radians. That doesn't happen in this next example. We have to find the inverse sine of the sine of 3 pi over 4. The sine from the unit circle, the sine of 3 pi over 4 is equal to square root of 2 over 2. And from page 3 of your notes, the inverse sine of square root of 2 over 2 is equal to pi over 4. So in this case, the inverse sine and sine did not cancel in the composition because the angle 3 pi over 4 is outside the range of the inverse sine function. And so they did not cancel. So this composite up here is equal to pi over 4 radians. All right, next we got to find the inverse cosine of the cosine of 7 pi over 6. Well, from the unit circle, the cosine of 7 pi over 6 is equal to minus square root of 3 over 2. And so this composite is equal to the inverse cosine of minus square root of 3 over 2. And from page 9 of your notes, we know the inverse cosine minus square root of 3 over 2 is equal to 5 pi over 6 radians. So again, the inverse cosine and cosine did not cancel in the composite because 7 pi over 6 is outside the range of the inverse cosine function. And so this composite up here is equal to 5 pi over 6 radians. Next we have the inverse sine of the sine of 7 pi over 6. From the unit circle, the sine of 7 pi over 6 is equal to minus 1/2. So this composite is equal to the inverse sine of minus 1/2. And from page 3 of your notes, the inverse sine of minus 1/2 is equal to minus pi over 6 radians. So this composite up here is equal to minus pi over 6 radians. And so again, the inverse sine and sine did not cancel in the composition because 7 pi over 6 is outside the range of the inverse sine function. And so they didn't cancel, and so this composite is equal to minus pi over 6. In the next example, we have to find the inverse sine of the sine of 11 pi over 4 radians. Now this is one of those times where it's easier for me to convert this angle into degrees and solve this problem in degrees. So the inverse sine of the sine of 11 pi over 4 radians is equivalent to the inverse sine of the sine of 495 degrees. Well, 495 degrees is equal to 360 degrees plus 135 degrees. So 360 degrees, you know, is 1 revolution around the unit circle, and then we got to go an additional 135 degrees to draw the angle 495 degrees. So the sine of 495 degrees and the sine of 135 degrees have the same value. And the sine of 135 degrees is square root of 2 over 2. So this composite over here is equal to the inverse sine of square root of 2 over 2. And from page 3 of your notes, the inverse sine of square root of 2 over 2 is equal to 45 degrees, which is the same as pi over 4 radians. So again, the composite, the inverse sine and the sine did not cancel in the composition. So the answer to our composite is pi over 4. They did not cancel because 11 pi over 4 radians is outside the range of the inverse sine function. So this composite up here is equal to pi over 4 radians. And lastly, we have the inverse tangent of the tangent of 2 pi over 3. Well, tangent of 2 pi over 3 from the unit circle is equal to minus the square root of 3. And the inverse tangent of minus square root of 3 from page 6 of your note packet is equal to minus pi over 3 radians. So again, this composite up here is equal to minus pi over 3 radians. And again, you can see the inverse tangent and tangent didn't cancel, and that's because 2 pi over 3 radians is outside the range of the inverse tangent function.